So here we have a small piece of plastic or cling wrap here. And if you ever used any of this wrap before, you probably have noticed that it sticks very well to glass or ceramic materials, like these, but not so well to wooden or plastic materials over here. Let's see, we have, for example, this glass. It sticks very well. It just tamps down to this glass right away, as opposed to it clings directly to the material. Same for this here, glass or ceramic bowl. It sticks very well. But then if we go over here to the wooden and plastic materials, we see it doesn't want to stick. It just stays hanging off the edge. Same for all of these others. So why is this the case? Why does plastic or cling wrap only work or stick to glass or ceramic materials? So this actually has to do with some interesting chemistry. So plastic wrap itself is made of long non-polar molecules, and what this means is a non-polar molecule is basically one where the electrons within that molecule are distributed evenly between the two atoms. They aren't all bunched to one side. They're non-polar, so they're evenly distributed. However, what we have in glass and ceramics is we have a highly polar distribution. So we have very polar molecules, which means that the electrons are really bunched to one side. And so a very interesting thing happens when you have non-polar and polar molecules coming together. What you have is a dipole-induced dipole attraction. And so essentially what that is when you have a non-polar molecule come close to a polar molecule, you have an attraction force there because of the forces taking place between the non-polar and the polar molecule. You've got your ordinary non-polar molecule, which comes into proximity with the polar molecule, and then you have an attraction force. This attraction force is precisely what keeps this cling wrap tamped down to this glass, because the cling wrap is extremely non-polar, while the glass is extremely polar. So what you have is you've got a dipole-induced dipole reaction between the non-polar material and the polar material right here. And with the wooden and plastic materials, you don't have that very polar difference there. We just have a non-polar material and another non-polar material. The plastic and the wood isn't polar in any way, so you cannot have an attraction force or a dipole-induced dipole attraction or anything like that. Which is why plastic wrap does not stick to wooden or plastic materials very well, and only works with glass or ceramics.